The ignition control module, or ICM, is a crucial component in gasoline-powered vehicles, especially those made before 2010. It acts as a switch, receiving low-voltage signals from the engine control unit and converting them into high-voltage pulses, up to 50,000 volts, which are then sent to the ignition coils. These coils generate the spark needed to ignite the air-fuel mixture in your engine's cylinders. Think of it as the conductor of your engine's ignition system. A bad ignition control module can cause a range of problems. Common symptoms include engine cranks but won't start due to no spark. Rough idling is another symptom. Engine misfires may occur, often showing a P0300 error code, reduced engine power or acceleration, stalling at idle or when driving. Check engine light illuminated, often with codes P031, P0360 related to coil issues. Backfiring. Excessive fuel consumption. If left unaddressed, it can even damage the catalytic converter due to unburnt fuel. Testing the ICM begins with checking for power. Use a digital multimeter to confirm 12-volt power at the ICM connector while the engine is cranking. Next, check signal integrity using an oscilloscope to verify square wave pulses at around 5 volts and 2 to 5 Hz at idle. You can also use an OBD2 scanner to read live data, such as coil dwell time. For bench testing, disconnect the ICM and apply battery voltage to simulate operation. A functional ICM should produce a consistent spark. If you suspect a bad ICM, start by cleaning the connectors and checking fuses. Replacing the ICM is often a feasible DIY job, costing between $50 and $200. For a more permanent fix, consider upgrading to OEM parts with improved heat sinks. Avoid cheap aftermarket units, as they tend to fail faster. After any repair, always clear the diagnostic trouble codes, DTCs, and take the vehicle for a 50-mile test drive. Real-world examples show how ICM failures affect different vehicles. These case studies highlight common patterns and solutions. GM trucks from 1996 to 2002 suffered widespread stalling caused by heat buildup around the ICM. This led to over 200,000 reported incidents. Many owners fixed the issue by relocating the ICM to a cooler area in the engine bay. Ford Mustangs from 2011 to 2014 experienced intermittent misfires, often due to faulty solder joints in the ICM. Owners found relief by upgrading to newer model ICMs designed with improved vibration resistance. In a real DIY case, a 2010 Honda Accord owner tested the ICM with a multimeter, found no pulse, and replaced it themselves. This saved hundreds in shop fees and demonstrates how basic diagnostics can solve ICM problems. These case studies underscore the importance of recognizing vehicle-specific ICM issues and applying targeted solutions. Automotive experts emphasize preventative maintenance through regular ECM scans to detect ICM issues early, potentially identifying problems before they cause major failures. A common problem is misdiagnosing ICM failures as coil problems, leading to incorrect repairs and wasted time. Statistics show that ICM failures account for 8% of engine breakdowns in vehicles over 10 years old, with average repair costs around $150. DIY fixes can be successful with basic tools, but professional diagnosis is recommended for safety to avoid overlooking related issues. With the rise of electric vehicles, the relevance of ICMs is declining. However, for internal combustion engines and hybrids, trends include modular designs with built-in self-diagnostics. AI-assisted diagnostics are also emerging, predicting ICM failures with increasing accuracy. The market for ICM replacements is shrinking, with a shift toward universal parts. While their role is diminishing, ICMs remain important for a significant portion of vehicles on the road today.